Moving onwards and upwards into our journey into organic chemistry, we're moving on to take a look at two other types of aliphatic compounds. Remember, aliphatic compounds are compounds that are just hydrocarbons and no benzene ring structure. If you don't know what a benzene ring structure is, that's fine. You'll be looking at it in later lessons. The last two of the last hydrocarbons that we want to take a look at are alkenes and alkynes. And here's where we start to get into those double and triple bonds that I've talked about briefly before. So alkenes are compounds that contain double bonds between carbons, and you can see that I have written that here for you. That's what it looks like. It looks like C equals C. That's not an equal sign. That's a double bond sign. Alkynes contain carbon-carbon triple bonds, and what that looks like is that. So triple bond between carbons. General formula for each of these. You can see that's written there. I want to draw your attention to the general formula for alkenes, CnH2n. We've seen this before. We've seen this general formula. Where did we see it? We saw it in our last lesson on cycloalkanes. Okay? What does this mean? Why is this significant? Why am I drawing your attention to this? Guys, the reason for that is because cycloalkanes and alkenes can be isomers of one another. Okay, so if you were given, for example, something with the formula C5H10, if you were just given that molecular formula, you're not sure whether that is an alkene, so 5-carbon straight chain with a double bond in it, somewhere between the carbons, or if it's a cycloalkane, so perhaps it's a ring structure of 5, so like a cyclopentane. You would have to have more information, or you would perhaps, i.e. in your homework, be asked to draw that out, draw out the different isomers. Okay? Alkynes, their general formula is CnH2n-2. That's important, and we'll see why in the next lesson. Both of these guys are what we call unsaturated hydrocarbons, which means they're actually bonded to fewer than the maximum number of hydrogens that each can contain. Now, again, that's kind of the sciencey textbook definition. The way I remember is it saturated, is it unsaturated? Unsaturated hydrocarbons will show a double or triple bond somewhere in the compound. Now, this shouldn't surprise you, the suffixes. So, if we're taking a look at an alkene, the name of the compound ends in -ene. If we're taking a look at an alkyne, the name of the compound ends in -ine, Y-N-E. All right, I've given you a list of the rules. I'm not going to read them to you. You guys can read yourself. Again, this is based on or kind of just grows from the list of rules that we had to name alkanes. That's our starting point. You need to really, really understand that before we start adding in different details. As you guys are reading over this, I want you to take note of number 2. So number 2 is what is different about alkanes versus alkenes or alkynes. So saturated compounds versus unsaturated compounds. Let's take a look at some examples. Here we've got a compound. And I don't really know in this particular compound why they've thrown the CH3s here. Could have done without them, so please don't think that those are branches. Also, why are these H's here? I don't know, okay? This is what happens when you steal things from the internet. They're not always exactly what you want them to be. So, let's take a look at this and go through the steps for naming as I have outlined them for you. So what we want to do, guys, when we're identifying our parent chain must contain the double or triple bond, whatever we have. Well, here we can see that we've got this double bond here. Okay, our parent chain must contain that. You will never have a double bond at or in a branch. Okay, so our parent chain must contain that double bond. What's the longest continuous chain that we can make of carbons? Well, it's going to be actually the only chain of carbons that's here. And this is going to be a little bit more simple than perhaps it looks right now. So we've identified our parent chain. Before I write the name, I'm actually going to number this because step 2, the numbering, the one that I asked you to pay really close attention to, is the one that is different, slightly different from alkanes. When we are numbering an alkene or an alkyne, so an unsaturated hydrocarbon, we need to give preference or priority to the location of the double or triple bond. So here we've got a double bond. What I want to do, and there are no branches here, but when we get into branches, keep this in mind. What I want to do is I want to give this double bond the lowest possible number that I can. So I need to start at the end closest to the double bond. Doesn't matter if there were branches close to this end here. Doesn't matter. The priority is for the double bond right there. Okay, so let's number this chain. I'm going to start here. This is, and again, so this is why I couldn't figure out why they put that CH3 there, because that's actually not a branch. It's just the end of the chain. 1, 2, 3, 4, 5, 6, and 7. Okay, I know with line diagrams, they're not the easiest to see sometimes. Just remember every time there's like an angle between two lines or two line segments, there's a carbon there. Okay, so our parent, guys, has 7 carbons. And it has a double bond at carbon 2. Okay, so the second carbon in the chain. Now, side note, the carbons that are involved in this double bond are carbon 2 and carbon 3. I always indicate the lower number, so I don't have to say 2, 3 or 2 and 3 or 3. I just need to say 2, and then everybody who's anybody in the organic chemistry world knows that you mean that's a double bond between carbon 2 and carbon 3. Okay, if the double bond went this way, we would call that the double bond would be at 1. Okay, so no one will be confused if you say the double bond is at 2. No one will say, well, is it between 1 and 2 or 2 and 3? Everybody knows that it's between 2 and 3. So that's, again, that IUPAC, International Union of Pure and Applied Chemistry, has set out these rules so that regardless of where you're studying organic chemistry, the rules for naming are always the same. Our double bond's at 2. Because it's a double bond, I'm dealing with an alkene, and so my suffix is going to be -ene. Because there are 7 carbons, my prefix is going to be -hept. Check in with yourself. How are you doing with the new counting to 10 using the organic prefixes? Hopefully you've got most of them down, okay, at this stage of the game. And if you don't by now, you will by the end of this lesson, I would bet, or by the end of the homework for this lesson for sure. I'm going to worry about putting all the name of that parent chain together in just a sec. Let's talk about branches first. Oh, wait, there are none. Okay, so now the time has come. How do we put this together? Now, I want to tell you a little story. When I was your age, we were able to call this compound 2-heptene. And that meant that the double bond was at the second carbon, and -ene meant that it was a double bond. And 2-heptene rolls off the tongue in polite conversation. And then the British came along. And as you may know, the British have quite often their own way of doing things. And they really like when other people want to do things their way as well. So what happened was the British were naming alkenes, alkynes, and some other compounds their own way. And then somebody decided, okay, well, we actually all need to be on the same page. And the page we needed to be on was the British one. So instead of calling this 2-heptene, which, as I said, rolls off the tongue, here's what we have to call this. If you take a look at how I wrote down for you guys the way that you put the name together, it's the prefix, so hept, then a dash, right? Because that's how we separate numbers from words. The number of the location of the double bond, 2, and then another dash to separate that from more words, and then the suffix. Hept-to-ene does not roll off the tongue. Again, I'm just the messenger on this. If everybody could name things my way, I like to think the world would be a better place. However, who am I really? No one's following my rules, including students in my classroom. So instead of calling this 2-heptene, it's called hept-to-ene. Now, why do I tell you that we used to be able to call this 2-heptene? Is it so we could make jokes about the British? That's not the only reason. Sometimes in reference manuals, you will see 2-heptene. Now, where you won't see 2-heptene is anything that I've given you. So homework, tests, quizzes, labs, assignments, blah, blah, blah. None of that will say 2-heptene. But if you go on, if you're fortunate enough to go on in organic chemistry, some places you may see 2-heptene instead of hept-to-ene still. Okay? Let's do a more complicated example. And I mean, really, the only way we complicate these things is by adding some branches. So here we have a wonderful structure that does have some branches, and our job is going to be to, first of all, identify the longest continuous chain. Now again, guys, these CH3s are not branches. I don't know why they're there. Okay, they are the ends of, well, either the ends of branches or the ends of a chain. So our job is, what is the longest continuous chain? And I mean, there's a couple of different ways that you could circle this one here. I'm just going to do this. Okay, you could start from this carbon and end at that carbon. You could start from this carbon and end at that carbon. But as long as at one end you've got, well, starting on the left-hand side, you start with one of these, and on the right-hand side you start with one of these. That way, or you end with one of these. That way you can get that multiple bond, the double bond here in this case, involved in the chain. Now this got a little bit messy, so pardon me. All right, let's number this bad boy. This is going to be carbon 1. Again, this is, you know what, I'm just going to cross these out. They are not branches, okay? This is going to be carbon 1, carbon 2, 3, 4, and 5. Not a branch. This guy, not a branch. Just the end of the thing. So, parent. I hope nobody's sad. I'm going to put this all together. So I've got my double bond here again at the second carbon. So that means between 2 and 3, I've got a parent chain that has 5 carbons in it. So pent, double bond at 2, ene, pent-to-ene. Where, oh where are my branches? So this part, I suspect most of us are pros at. So I've got this branch here, which is, again, that's not a second carbon. I've got this branch at number 2, which is just a methyl group. Okay. And then I've got this branch at 3, boom, boom, which is an ethyl group. Okay, because there's 2 carbons in the branch. Eth is the prefix for 2. Il is the suffix for, to indicate that it's a branch. Wicked. Let's put this name together. What do we have to remember here, though? We need to make sure that we keep in mind that we're not listing our branches in numerical order, but rather alphabetical order. So E comes before M. So this is going to be, I think, a long name. 3 ethyl, 2 methyl, and then all one word. So we're still using all one word for everything, just sometimes separated by hyphens. Pent, 2 ene, magical. 3 ethyl, 2 methyl, pent, 2 ene. And again, remember your punctuation here. Two more examples to go through. Finally, we get to see one with a triple bond and one that doesn't have CH3s hanging off of it that don't need to be there. In this one, I know it looks, you're probably looking at this and thinking, where are all the H's? Okay, well, just pretend that I wasn't lazy and that I actually at least drew for you in these lines. There you go. So if you're very confused, that's what it should look like. Should. Okay? What's my longest continuous chain that contains the multiple bond? In this case, we're dealing with a triple bond. It's new. It's exciting. There it is. And then which end do we start numbering from? Looks like the left. 1, 2, 3, 4, 5, 6, and 7. Cool. Guys, at any time in these videos, you can definitely pause, do your own thing, figure out the example on your own, and then check in with me afterwards and make sure that, that you've got it going on. Here's our parent. 7 carbons, so prefix is hept. Where's my multiple bond? It's on the 3rd. And what kind of multiple bond is it? That is a triple bond, friends. So we are ending this in -ine. Hept 3-ine. Fun. Branch. Just one of them. Okay, this branch has 2 carbons in it. It comes off the 5th carbon in the chain, so it's a 5 ethyl. Putting the name of this all together, ethyl hept 3-ine. So as you can see, that's why I put alkenes and alkynes together, is because the rules for naming them are exactly the same. Whether you're talking about a double bond or a triple bond, the only thing you have to keep in mind is what is that suffix going to be. Last example. Here we go. I don't know if this is just my vision or if this is blurry on your handout as well, but we're going to make the most of it. We shall do our best here. Okay, so we have a condensed structural formula, and again, wanting to find the longest chain that contains the multiple bonds. So this is our multiple bond right here. In case it's too blurry for you guys, it's a double bond. So definitely these 2 carbons are going to be involved. Okay, and then to make the longest possible chain, we probably just want to go there. That got messy. All right, numbering. 1, 2, 3, 4, and 5. Cool. So what's my parent then? Pent, because there's 5 carbons. 1. Now we see that the double bond is off the 1st carbon, and so even when it's off the 1st carbon, guys, we still need to indicate where it is, so you will put that 1. Pent 1, and I said it was a double bond. Even though the picture's so blurry, no one can really tell. That's what we'll call it, pent 1-ene. Branches are found on the 2nd carbon from the parent chain and the 3rd carbon. On the 2nd carbon, we've got a methyl group. And on the 3rd carbon, ethyl once again. Putting this whole name together, again, remembering alphabetical order, 3 ethyl, 2 methyl, pent, 1 ene. 3 ethyl, 2 methyl, pent, 1 ene. Maybe doesn't roll off your tongue quite so much, but you know, do your best. Homework with this, you guys are going to want to get a lot of practice in so you can get used to following those steps. Good luck, enjoy, come see me if you have questions.